In this section of chapter 20, I'll talk about electrochemistry, basically where you get electricity by using chemical reaction. That happens in case of a battery. Within the battery, chemical reaction takes place, and that's how you get electricity. We are also going to discuss about balancing of electrochemical reactions. Now, electrochemistry deals with, as I just mentioned to you, deals with electricity and chemical reaction. The type of chemical reaction used is called oxidation-reduction reaction, and that happens simultaneously. So there'd be one oxidation reaction where electron would be given off, and another reaction would be reduction reaction where electron would be absorbed by the reaction. So oxidation is defined as loss of electrons or increase in oxidation number. Reduction deals with gain of electrons or reduction in oxidation number. What you are seeing here is a typical oxidation reduction reaction, and in this case zinc is oxidized to zinc 2 plus. In other words, its oxidation number has increased from 0. This zinc doesn't have any oxidation number, so pure element and without carrying any positive or negative charge would have 0 oxidation number, and that increases to plus 2 when it becomes zinc plus 2. Copper 2 plus, on the other hand, is reduced in oxidation number from plus 2 to 0. So increase in oxidation number is called oxidation. Decrease of oxidation number is called reduction. So based on that, we can say that zinc is oxidized to zinc 2 plus and copper 2 plus is reduced to copper. In case you were wondering, in a reaction like this, how do you get copper 2 plus? Because you cannot isolate one positive or negative ion. So you basically need to add copper nitrate. That would bring copper 2 plus or copper sulfate. Similarly, zinc 2 plus would be just a part of the ion. The other ions come from zinc nitrate or zinc sulfate. Now, oxidation reduction reaction happens simultaneously. Just like in a football game, you need to have a quarterback and a receiver. In the reaction that I have shown in previous slide, zinc basically is giving up 2 of its electrons, and copper 2 plus is receiving those 2 electrons and becoming copper. So zinc becomes zinc 2 plus after losing electrons, and copper 2 plus becomes copper. And this happens simultaneously. In other words, there cannot be a fumble here. That means zinc, whenever it gives up electron, it must have a receiver. Otherwise, it's not going to lose its electrons. So keep this in mind. In electrochemical reaction, one reaction will have to give up electron, and there should be another reaction that would absorb those electrons or receive those electrons. Otherwise, there'd be no exchange of electrons. Now here we are showing you contribution from zinc and copper separately. These are called half reactions because we're showing their contribution separately. Zinc becoming zinc 2 plus and 2 electron. So this makes 1/2 of the reaction. The other half reaction deals with copper 2 plus that receives 2 moles of electrons, giving 1 mole of copper. That's the other half of reaction. So every electrochemical reaction, in every electrochemical reaction, you'd be able to split the reaction into 2 half reactions. And that's comparable to a role played by a quarterback, like zinc is like a quarterback, is throwing electrons, and copper 2 plus is acting as a receiver, and it receives those 2 electrons, becoming copper. So the net reaction is the bottom one. Zinc plus copper 2 plus giving zinc 2 plus copper. How do I get the net reaction? just like any addition of any two reactions, and you can apply algebra here. For example, in this case, I have 2 electrons in first reaction, 2 electrons in the second reaction, but one is on the right side, the other one on the left side, so it can cancel out. So that would give you the net reaction, zinc plus copper 2 plus, giving zinc 2 plus plus copper. Here we are going to define what is called oxidizing agent and reducing agent. So let's look at this reaction again from a different angle, just showing zinc and copper 2 plus. What zinc is doing is throwing its electron pair, and copper 2 plus is receiving electron pair. The question is, who is helping zinc in throwing off electrons or in loss of electrons? Obvious answer is copper 2 plus. If copper 2 plus were not there, there'd be no loss of electrons from zinc. So copper 2 plus is helping in oxidation process. So that's why copper 2 plus is the oxidizing agent. In a reverse manner, I can ask this question, who is helping copper 2 plus in receiving electrons? If zinc was not there, then there'd be no receiving of electrons by copper. So who is really helping in this reaction? Zinc, by throwing its electron pairs or losing electron pairs to copper, is really helping copper to gain those electrons. So zinc is going to be reducing agent because it helps in the reduction process by giving off its electrons. So which one is the reducing agent? Answer is zinc. So whichever helps in reduction process would be the reducing agent, and whichever is helping in oxidizing process would be called oxidizing agent. So make sure you know all these definitions. Now, these reactions are also called redox reaction, reduction oxidation reaction. And this is pretty much a review of what we just discussed. We split a reaction into 2 half reactions so we understand how many electrons got transferred from one half reaction to the other half reaction. In this particular case, it's 2 moles of electrons. And in some calculations, it will be important. This is a very important information for you. So make sure you recognize this. And I already mentioned that copper 2 plus is oxidizing agent, sometimes called oxidant. Zinc is the reducing agent or helps in reduction process, often called reductant. Now let's go over one balancing of oxidation reduction reaction by selecting a problem from your homework. And I'm going to go over number 23C. So let's go number 23C. The question is that balance the reaction. I'm going to, when I write down this question, I'm going to ignore a state of the matter like solid, aqueous solution, all those, just to save my space because I don't have enough space here. Hope I can finish this one. I selected the same slide where I have the rules because that way you can understand it better. In next couple of slides, I will be doing additional problems, but this one is important as I go over each rule and show you how to apply the rule. So this is the reaction. Question is balance it in acidic solution. So you'd have a different balancing if it is acidic compared to whether it's basic. Okay. So we are going to, this rule is applied. The rule that I have written down on the left hand side would automatically give you balancing in acidic solution. To make it basic, you need to add OH minus at the end, and I'm going to show you that. Now, in book, they have described 2 different rules. One for balancing in acidic solution, the other one is balancing in basic solution. I thought that it'd be easier for students to follow one rule and know how to change from acidic to basic balancing. And that's exactly how I'm going to do this problem. The first step is split a reaction into two half reactions. So how do I split that into two half reactions? Based on similarity. I have on the left side I2, on the right side I have IO3 minus. So same iodine is there. So my first half reaction would be I2 giving IO3 minus. So that's what I have done. And the other half reaction, I think I'm going to write down with a different pen, so that I'm going to write down on the top. Other half reaction would come from OCl minus and Cl. So my other half reaction, OCl minus giving Cl minus. So I've written down two half reactions. Make sure you understand that, how I split that into two half reactions. You should have at least one of those elements in common other than hydrogen or oxygen. Okay, now I'm going to balance each half reaction. Let's begin with this half reaction with iodine. So balance element other than hydrogen and oxygen. So I have two iodine on the left side and only one iodine on the right side. So how do I balance it? I must have 2 in front of I, so that makes it 2 iodine. So I first did that, balance elements other than hydrogen and oxygen. Then I need to balance oxygen by adding H2O. I have 6 oxygen on the left hand side, 2 times 3. So that makes 6 oxygen on the left side. So I must have 6 H2O on the other side. So that gives me 6 oxygen. Next rule is balance hydrogen by adding H+. I have 12 H on the left hand side. 6 times 2, that's 12. So I must have 12 H+. That's how you balance it. You have to strictly follow these rules for balancing. 12 H+ in order to balance hydrogen. Next, you need to balance the charge by adding electrons. Let's see what we have. On the left hand side, no charge. I2 is neutral, 6H2 is neutral, so there is no charge on the left hand side. On the other hand, on the right hand side, I have -2 coming from 2 of IO3 minus. Each IO3 is -1, so 2 times -1 is -2. I have H has +1 and I have 12 of them, so it's +12. So at this point altogether I have +10 on the right hand side and 0 on the left hand side. You're only allowed to add electron in balancing charges. You're not allowed to add protons. So each electron is like -1. So obviously I need 10 electrons on the right side so that it would be neutral now. When I added 10 electrons, it becomes -10, so it becomes 0. So my left hand side total charge is 0, right hand side my total charge is also 0. So now I balance the first half reaction. Let's try the other half reaction, which is OCl minus and Cl minus. So I'm going to do that, changing the pen color. So again, writing down the other half reaction, OCl minus, Cl minus. Again, applying the rule, balance element other than hydrogen and oxygen. I have only Cl here, and I have 1 Cl on each side. So I don't need to do anything and skip for that particular rule and go to the next one. Balance oxygen by adding H2O. I have 1 oxygen on the left side, so I must have 1 H2O on the right side. Then I need to balance hydrogen because I have now 2 hydrogen on the right side, so I balance it by adding 2H+ on the left side. So 2H plus on the left side. At the end, I need to balance electron, balance the total charge on both sides, make sure charges are balanced. Let's see what I have on the left side. 2 of H plus. Each H plus has plus 1. So 2 times plus 1 is plus 2. OCl minus, that's minus 1. So at this point, I have plus 1 on the left side. On the right side, I have Cl is minus 1, so it's minus 1, and water is neutral. So I have plus 1 on the left side. Net charge is plus 1 on the left side and minus 1 on the right side. Remember, I need to balance charges only by adding electrons, and each electron would contribute minus 1. So only way I can make it minus 1 on the left side would be by adding 2 electrons. So let's add 2 electrons, and that makes it minus 2 on the left side, and thus now both sides would have minus 2. So I'm done with both half reactions, but now I need to apply, before I add them together, make sure we balance each half reaction in such a way so that number of electrons is the same for each half reaction. First half reaction, I have 10 electrons on the right side. In other words, given off. You think it this way. The reaction not only forms products, it also forms 10 electrons. And second half reaction shows that it absorbs 2 electrons. This imbalance cannot exist. Remember I mentioned about if one half reaction gives off 2 electrons, the other half reaction will have to receive those electrons. Now this is 10 electrons, so you'll have to get 10 electrons for the other half reaction. So what do I need to do? Multiply this by 5, because there has to be same number of electron transfer from one half cell to the other half cell. Otherwise there'll be no such transfer of electrons. So when you multiply the whole reaction by 5, you end up with the following: 10H plus 5 OCl minus plus 10 electron, giving 5 Cl minus plus 5 H2O. If you carefully look at it, now I have 10 electrons in both half reactions. In first half reaction, I have 10 electrons on the right. Second half reaction, I have 10 electrons on the left. And that's how it should be, because having 10 electrons on the right means it gives off electrons, and on the left means second half reaction absorbs electron in its reaction towards the product. Now we are going to add those two reactions together. So for that, I think it would be a good idea to write down one underneath the other. So that's what I'm going to do. I'm going to copy the other reaction here too. So let's do it. This is the balanced reaction. I'm going to copy the other half reaction. I2 plus 6H2O giving 2iO3 minus plus 12H plus 10 electron. Now I'm going to add them together. This is like an algebra. Left hand side can cancel out with right hand side. I have 10 electrons on the right side coming from the second reaction. In this case, let's draw a line here. So I'm going to cancel out. Let's use a different color of the pen. So 10 electron canceling out with 10 electron canceling out. Now, do I have anything else that I can reduce? Yes, you can have H2O reduced. I have 5 H2O on the right side, 6 H2O on the left side. So let's bring that 5 H2O from right to the left. So in other words, you subtract both reactions, subtract 5H2O from both sides. So minus 5H2O here. And then basically this 5H2 will be gone because you subtracted that. Now anything else in common? We have H pluses, 10 H pluses on the left side and 12 H pluses on the right side. Again, subtract 10 H pluses from both reactions. So this 10 will be gone because I'm subtracting, minus 10 H plus. Now that's going to reduce my equation. So now I can write down the overall reaction. So the net reaction will be given by addition of these two, 5 OCl minus plus H2O, because 6 minus 5 plus H2O plus I2, that gives 5Cl minus plus 2IO3 minus plus 2H plus. So by applying this, I got a balanced reaction. This is the net reaction, which is already in acidic solution. In acidic balancing, always there be H plus in that net reaction. This question is asking us to balance it in acidic solution, and we did get it in acidic solution. If you want it in a basic solution, what you need to do is at the end, after rule 7, apply 8. That means to balance the reaction for a basic solution, add number of OH minus equal to number of H plus in the reaction. So if I want to, this is acidic, let me write down here. So this is acidic. In order to make it basic, what you need to do, follow my red pen, add 2 OH minus, because that's the rule. Whatever H plus you have to add same number of OH minus. So if I'm going to add 2 OH minus on the right, I must also add 2 OH minus on the left. How is it going to change it? H plus and OH minus, that makes H2O. So basically, from here, 2H plus and 2H OH minus, I get 2H2O. So now, for balancing in basic solution, I have 2H2O on the right side, and I have H2O on the left side. So again, I can reduce that, and that H2O can bring over there. So that would, overall, you can get 5 OCl minus. Keep in mind, this is the basic balancing, and you're not required to do it for this particular problem, but for other problem you need to do this if they're asking to do it. There will be 2 OH minus plus I2 giving, I need to use a different pen because I ran out of space here. That gives me keep in mind this H2O would be gone, it would be minus H2O from right side. So that would give me 5Cl minus plus 2IO3 minus plus H2O. I hope I haven't left out anything. Make sure you double check it. Since I ran out of space, I could not double check. So that bottom one is the balanced reaction in basic media. Again, just like the previous reaction, we are going to split this reaction into half reactions before I balance it for acidic solution. So I'd do it so that it'd be good practice if you can do it. So Cr2O7 2 minus Cr3 plus. So that's going to be my 1/2 reaction. The other half reaction will be I minus and IO3 minus. So keep that in mind. I am going to write down because I don't know how much space I would have at the end. IO3 minus, that's the other half reaction. This is I minus giving IO3 minus. I think this should not be plus. Giving IO3 minus. Now, let me remind you that again, first I need to balance elements other than hydrogen and oxygen. So there are 2 chromium here, 1 chromium here, so multiply by 2. Now balance oxygen by adding H2O. Now I have 7 oxygen on the left, so I must have 7 H2O on the right. Now I have 14 H on the right, so I must balance by adding 14 H plus. Now let's count charges and balance the charges. At this point I have plus 14 coming from 14 H plus. Each H plus is plus 1, so 14 times plus 1 is 14. And minus 2 is coming from Cr2O7 to minus. So now I have plus 12 on the left side. On the right side I have plus 6 coming from chromium. Each chromium is plus 3. 2 times plus 3 is 6. Now on the right side I have plus 6, left side I have plus 12. We'll have to have same charge on both sides because charges need to be balanced. Remember, I can only add electron to balance charges. So I need to add 6 electrons to make it minus 6 on this side. So 6 electrons would make it. So if I have minus 6 here, that would become plus 6 on both sides. And now I have balanced charges. Now let's write down the other half reaction. I becoming IO3 minus. First balanced element other than hydrogen and oxygen, and we don't have any hydrogen and oxygen. And I have only one I on each side, so I don't need to do anything. Now then balance oxygen by adding water. I have 3 oxygen on the right side, so I must have 3 H2O on the left side. Now I need to balance hydrogen. I have 6 hydrogen on the left side. I must have 6 H plus on the right side. Now let's balance charges. I think I forgot something here. The I is minus. So on the left side I have minus 1 coming from I minus. On the right side I have minus 1 coming from IO3 minus and plus 6 is coming from hydrogen. So altogether we have now plus 5. So minus 1 on the left side, plus 5 on the right side. So I must have 6 electrons on the right side. So that makes it 5 minus 6, that's minus 1. So now you have minus 1 on each side. And now let's see how many electrons would be received by first reaction. Left hand side, having electrons on the left hand side means that particular reaction is going to absorb electron or receive electrons as it gives products. So 6 moles of electrons would be received by first half reaction and 6 moles of electrons would be given up by second half reaction. So there is a balance already. If there is an imbalance, we'll have to make them equal. So now we can add them up and that would automatically give you a balanced reaction in acidic media. Remember balancing, you have just like an algebra, 6 electrons cancel out, and then you just take care of water. You have 7 H2O on the right side and 3 H2O on the left side, so that would reduce to 4 H2O. I would like you to complete this balancing. In this problem, I'm going to show you the setup, and I would like you to finish up this. First, again, the half reaction would be ClO2 and ClO2 minus. So ClO2 is one half reaction giving ClO2 minus. The other half reaction would have, obviously, H2O2 and O2. Again, first balance the reaction. balance the element other than hydrogen and oxygen. So it's 1 and 1. So next you need to balance oxygen by adding H2O, but oxygens are already balanced, so I don't need to worry about it. And third step is balancing hydrogen. There is no hydrogen here, so there is no balancing of hydrogen. And now we need to balance the charge. There is no charge on the left side. There's -1 charge on the right side. So in balancing, I'm going to add 1 mole of electron. So that's, I'm done with the first half reaction. For the second half reaction, let's do H2O2 giving oxygen. First we need to balance element other than hydrogen and oxygen, and there is no such element, so don't need to worry about that. Then you balance oxygen by adding H2O. Again, oxygen is already balanced, so I don't need to worry about that. Next, balance hydrogen by adding H+. I have 2 hydrogen on the left side, so I must add 2 H+ on the right side. Now I need to balance charges. What I have on the right side, I have +2, and I have no charge on the left side. So what I need to do, I must add 2 electrons. In first half reaction, I had 1 electron on the left side, and the second half reaction I have 2 electrons on the right side. So you can't have this imbalance. So you must have 2 electrons. So multiply the first reaction by 2. So that would give me, let's write down that product here at the bottom. 2 electron plus 2 ClO2 giving ClO2 minus plus, so let me double check this, 2 electron times 2 ClO2 giving 2 ClO2 minus. I think we are pretty much done with it. So now when you add them up, 2 electron cancel out 2 electron, and I would have H2O2 plus 2 ClO2 giving 2 ClO2 minus plus O2 plus 2H plus. That's acidic balancing. The question is about basic. So what you need to do, you need to add 2 OH minus on both sides. I hope I'm not leaving out anything. So that's 2H plus and 2 OH minus would give you 2H2O. So this would be 2H2O. I'm just saving some steps because I'm running out of space here. So this red one, let's write down H2O2 plus 2 ClO2 plus 2 OH minus giving 2 ClO2 minus plus O2 plus 2 H2O. So this is the basic, because I have OH minus, and so that's the basic balancing. Make sure you double check my my solution so that you can find out if I have made any mistake.